Welcome back, everyone, to our machine learning session where we were learning about scikit-learn libraries and how you are going to create your first ever. Imagine like you are in HR and or maybe you are a business person or you are a CEO, or because we all are moving towards entrepreneurship. So suppose you have started your business and there you need some more candidates, right? And you wanted to train an HR, or you wanted to hire an HR like other companies and everyone does. And every time when you give or you train your HR to find the right candidate for the work which you wanted to get done, he learns it, and after a few months when he gains the experience, he left, right? So how about you are going to create a machine learning model which is going to take away the work of an HR, or hire a person who can run or who can be equipped with ML or AI functions, who is going to get your works done. So similarly, this program which we created or which we are creating, which is right now in progress using scikit-learn and machine learning, that is all about predicting income, all right, of a person who is not in the system. Suppose I am an HR and or I am a machine who is trained to finalize or do salary negotiation. So for that, what I'm going to do, I'm going to just click, I'm going to fill the image, or you can say, I'm going to just put the number of years of experience that person has, and it is going to provide the expected salary. And based on that, and based on the experience that person has, I'm going to share that this is the expectation which you are going to get, right? So this is the model which we all are creating. So in the previous class, we have seen how you are going to use pandas, Seaborn, Matplotlib, PyPlot to actually see and visualize the pattern, as well as scikit-learn to split the data into test and train and to see how it is going to go. Now, in the previous class, we have discussed how you are going to predict the error percentage, because obviously every project or model which you are going to create by using machine learning is not 100% true, right? So there is a margin of error. So how you are going to calculate that error and provide this error among your clients so that they'll get to see that this much of error you have to accept, and that acceptable window. All right. So that your client is going to be satisfied and he or she is going to negotiate accordingly. Right. So in the previous class, we have seen the difference between the actual value and the predicted value. And we have done multiple libraries and we have understood how machine learning linear regression does by using y is equals to mx plus c. Now, after doing that, let's see how to calculate error, which is mean absolute error and mean squared error, by using multiple, or you can say matrices library of scikit-learn, and how you are going to calculate it using Python code. All right, so let's quickly go and let's see how you are going to understand that. Previously, we have seen, I have calculated it on the Excel sheet that this is the actual value and this is the predicted value, and we have done the subtraction and we have seen how this error is going to be calculated and what is the significance of mean squared error as well as mean absolute error. So let's quickly open your Visual Studio Code and let's get started. Now, to find the square root, what we are going to write, we first have to import maths. In some of the systems, or some of you might do that without importing maths also, but mostly you have to import maths in it. And then you are going to write print math squared error. And then if you are going to calculate the accurate value of that, you will be getting. Let's do it. And I'm going to press enter over here. And now you can see. So this is the squared error and this is our absolute error. Now you can see that there is very less difference in both. And this is what you are going to provide to your clients when you are going to provide this model to them. Now, one more thing. Now we wanted to see how the output is going to look like. So for that, let's quickly write for the output, and what you are going to do, type print and we are going to write print as output. Output is, and then we are going to say print the model which we have created, model dot predict, and this model prediction is going to be inside this. We are going to write for 5, who is 5 years of experience, who is 20 years experienced, as well as who is 12 years of experience. And we have not given like who is 100 years of experience. Let's try that also. So let's give 100 years of experience. So this is the data which we have. And now let's see how it is going to go ahead. Okay, I'm going to press enter. Okay, it shows that model.predict, it has certain issues in it. Let me see what exactly is the issue in this. Model.predict. Okay, so this is going to be an entire list. So I'm going to put this inside this list. Okay. Now I guess it's completed and now I'm going to run this. Okay, and I'm going to enter. Now you can see. So who is like 5 years old, the salary is going to be, it should be around 50,000, but as of now, the prediction is showing 49,764. And who is 100 years of age, that you can see, ones, tens, 100,000, 10,000 lakh, 10 lakh, 10 lakhs approximately, and there is huge number. So you can see how the prediction is running and basically how the person is going to gain the salary. So this was the entire model, and I'm going to show you how it is going to work. Let's quickly recap, okay, what we have learned and how we have created this model by using different sklearn or scikit-learn libraries in it. And I'm going to explain each library in depth. This is the first model, which is related to linear regression, which we have created. And catering to this model, most of the things and most of our models are going to be same. The only change which we are going to do in that, that is going to be that we are going to fetch the data from different data sets, or we will be using different data sets, as well as the classification method and manipulation or whatever decision trees which you are going to use, that manipulation part is going to be different. Rest, all the steps are going to be same. So this class was really, really important in terms of understanding how you are going to prepare the data, what exactly you are going to put in the data, and how the data is going to work in a model, how you are going to represent thinking about the perspective of your client. So let's quickly recap. So first of all, we created our data in Excel. We have defined two particular columns. One is years of experience and the second one is salary. We have kept it in an increasing order in terms of that it looks easier and we can find the patterns easily. Now, once you have created that, we have fetched the data, we have saved the data set into CSV so that it is easily readable and we can use it in Python. So therefore, to read the data, we have used pandas library. So over here, we have imported pandas as PD and we have created a data frame and we have read it. We have fetched the data by using read CSV and we have seen how successfully it is going to be encountering into our system. Now, once you have received that, by using Seaborn library as and PyPlot, Matplotlib, we have visualized the data to find out if there are any patterns in it. Without patterns, we cannot run or create any data or any prediction. So therefore, this is a very, very important part. Once we have done that, we have split the data into two parts by using scikit-learn test and train and test split. As you can see over here, scikit-learn model selection, import, test, train, split. So by using this particular library, we have split the data into two parts. Over here, as you can see, the test size we have kept 0.2. With respect to the data, if you have large amount of data, you can increase the test size also, else 0.2 means 20%. You can increase it to 40% or 50% depending upon the data which you have or the model which you are creating. Once you are satisfied with that, we have used random state also. Random state, why we have used? Because every time we wanted to test from a set of testing data, not beyond that. Otherwise, it is going to use the data from the training segment. We want our model to use a specified test data which is untouched. Now, the next part is we have seen we are now going to train the machine on the data set to find different patterns. For that, we have used a linear regression library of sklearn, scikit-learn. With linear regression as an object, we have called upon here, and we have used model.fit to make sure that my machine is going to learn or get trained on X-train and Y-train in both the columns. X-train and Y-train are X and Y both we have created, and these two variables we have stored the data which are years as well as salary. Now, why predict is like how the prediction is on the basis of the test. So basically, it's like when you are giving examination after learning, how it is matching whether you are able to clear the test or not. So this is why predict. Now we are going to see how this why predict is differentiated or is different from the actual why data, the actual data which we had. And over here, you can clearly see that actual data is this, and this is how the prediction looks like. So this is how it says. So over here, the prediction as well as the actual data, you can see the split part of both, how it is different from each other. So this is what machine has provided, the predicted data, and actual data, which is we have given, we have defined. So once we have done that, we are now satisfied that this is our model, but we have seen some discrepancy also. And this is how the data looks like. For 0 years of experience, we have seen that the actual value which we have defined, that was 15,000. And the predicted value which machine learning and our model has given, that is 14,356. And this is the difference. When we have calculated the total difference, it come across that there was a discrepancy of minus 5,356 in actual. Therefore, we see that this discrepancy is not as per individual entry. It is an aggregate one, so which is going to be a wrong data, a wrong assumption which we are providing to the clients. So therefore, we have introduced another, which is another error finding formula, that is mean square value and uh, absolute error. So we have introduced that from scikit-learn matrices. We have import both the libraries, and we have used these libraries to find out the errors and to fix it, to provide an insight that this much of discrepancy is going to come if you are going to use this model. So therefore, finally, we have predicted by using model.predict for 5 years, 20 years, 12 years, and 100 years, how the salary is going to be. If you would like to change and find out how much the salary is going to be for a person who is, let's say 50, who has 50 years of experience. So let's quickly calculate that. And I'm going to do this. Now let's run this. I'm going to enter over here. And you can see who has 50 years of experience, the salary is going to be 50,000, 50 lakhs, 50,090. So this is going to be the salary. And I hope you are also able to visualize and find out what salary, if you are 10 years of you have 10 years of experience, how much you will be getting, and who have 12 to 20 years of experience, how you'll be getting. And now make sure, because the data which we have provided, that was let me show you, that was till 6 or 7 years, I guess, maximum 11 years. Now we are able to calculate for 50 years, 100 years, 20 years, whatever. Even if you are going to write 200 years of experience, maybe vampires do exist at that point of time, then you will be able to get that also. Because in this, as I'm going to show you the chart, this straight line, you can stretch it to infinite. And it will be able to tell with basis on that, like if you are going to draw this, it will be telling. So suppose if you are going to extend it, and here the value is going to be like the years will be 50 approx. All right. So if you are going to extend this year and this falls to 50, right? Then the salary will be calculated accordingly, that he or she is going to get 50 more, like this. I hope you have understood how scikit-learn works, what libraries you will be using, how and when. You must have understood why I dropped X, because it was considered as a series in pandas. We usually work when we are running any machine learning model or prediction. It uses two-dimensional data. So how we have utilized and fixed that issue. Along with that, we have understood how to calculate mean squared error and absolute error, how you have utilized pandas, you have used Seaborn, Matplotlib to visualize the data. So So everyone, our model is complete. So let's quickly revise all the steps, because these are the steps which you are going to follow in all machine learning models, whatever classifications you are going to run, whether that is linear regression, multi-regression, multi-class regression, reinforce. So all the classification and manipulation methods are going to follow the same steps. Okay. Only mathematical or decision trees, the classification method is going to be changing depending upon the data and the model which you have selected to create. And I'll be explaining each and every model among all of you. So let's quickly move how you are going to set this up. So step number one, what we did, we imported multiple libraries to support the model, which is our machine learning income prediction model. The first one is we have imported Python libraries, which include pandas, Seaborn, Matplotlib. Then we have taken scikit-learn model, selection scikit-learn linear model, scikit-learn matrices for mathematics. Now, you already, I have multiple times explained this thing among all of you, that why we have catered to these libraries. Pandas we have taken to run and to create data frames and to fetch the data, to save the data in data frames. Then we have taken Seaborn Matplotlib to visualize the data, to find certain patterns, to see what kind of graph it is going to create, and to see whether there is any pattern onto which we are going to create our prediction model. Then we have scikit-learn model selection to run the analysis on the basis of test and train. We split the data. Then we have taken scikit-learn linear model to actually see and create line graph which calculates y is equals to mx plus c, so that we can actually create and see how our testing and training is going to take place. Thereafter, to find and to match or to find the error in it, we have taken scikit-learn matrices and maths. So I hope you also have taken all these libraries. So let's move to the next step. The next step which we have taken, that was load and view data set. By using Python pandas data frame, we have load data by using td dot read CSV, the CSV which we created. We have read it first. First few rows using df.head, as well as we have the data set that contains salary data for the prediction. Then we had data splitting in it by using Matplotlib and scikit-learn library. We have separated the features in X and Y. X is going to be our input and Y is the target. Then we have used train test split to create training and testing sets. Along with that, we have split the data into 80 and 20 ratio for the testing and training. I hope you remember random command as well as split size. So these are very important models, or you can say modules or methods with which you are going to make sure that your prediction is going to be accurate. Step number 4 was model training and prediction using linear regression and fit method model on training data. We have trained the machine by using 80% of the data from our data set. Thereafter, we have predicted target values using model prediction on test data. After that, step number 5. Step number 5 was very crucial and very important step. It was model evaluation, where we have compared the actual value with the predicted value. And thereafter, we came to know that there are certain errors. When we did whatever is the actual value in our data for 5 years or 6 years or 7 years, the data was varying when machine learning actually predicted the amount of or salary of those particular individuals. Then here comes the role of mean absolute error, which is MAE, and root mean squared error, which is RMSC. Therefore, and why we have calculated it, let me just give you a quick overview because this is a very important step. And most of the interviewers, when you are going to share that you have predicted and you have created a model on machine learning, income prediction, then they are going to ask you, how much accuracy did you provide to the client, or how much is the accuracy of the predicted model which you have created? So based on that, you can explain that there was discrepancy in the data which we have calculated by using MAE and RMSC, and why it was important, what was the reason behind it. So that all you can explain. Let me quickly share why it is important. So when we calculated that there is a discrepancy in actual and predicted value, first of all, we compared it, we subtracted the model, and we came across that there is this much. So suppose if the actual value was 4,000 and our model has calculated 3,800. So 200 is the discrepancy. So accordingly, you are going to calculate the same. When you are going to, then there are certain values when the model has predicted more, and the values which when you are going to subtract, it is going to come in negative. Therefore, to eliminate that error, we usually square the value so that the negative is going to turn into positive. Again, to come to meet with that value, we needed to root mean square error. I hope you remember that we have done that practical. Thereafter comes step number 6, which is predict new value. After completion of that model, we predicted the salary for 50 years of experience using model.predict. And instead of 50, you can write anything. In fact, you can take user input also. Final output is the predicted salary value. I hope you have enjoyed this entire session, as well as you have enjoyed by creating your, in fact, you can actually predict your own salary. So likewise, keep learning. You can change the data set, or you can take any other prediction like this. You can do one more thing to fit with that role. So you can mention the role and number of years, and you can see that a person who has this much of experience, they can usually go via it, otherwise not. So likewise, you can predict and you can share. Keep sharing your inputs with us, which is very, very important. And I hope you like this session and you have learned a lot. Stay tuned with us. In the next class, we are going to come up with a new model, and we are going to run our new analogies with a new set of data. So stay tuned with us, and thank you everyone for joining the session and for giving the valuable feedback.